Hello, Abstract Algebra students. I am screencasting your course for the fall. My hopes are that you will never see this video because we will be back in person. But Abstract Algebra is challenging enough, so you're probably not going to be able to learn it just from reading the notes. And it's fast enough, so I can't screencast it in real time in the fall. I believe in Murphy's Law. By the fact that I'm screencasting this now, hopefully you will not ever have to look at it. We shall see. So, as I do this, to give the impression that I'm writing on the board, I'm going to type what I would write in the board into my virtual Blackboard or Word document. Please understand that I can write faster than I can type. Typing equations is painful on Word. And please also understand that I'm not going to go back and edit these films. So you will hear some ums and some pauses and that kind of stuff, just like you would if I were speaking in the lecture. So with that in mind, let's get started. Our first lecture is on section 1 of the textbook, lecture 1. And it's going to be on properties of operations. So abstract algebra is the study of algebraic structures. So we should begin by talking about what is an algebraic structure. Now, an algebraic structure has 3 different pieces to it. An algebraic structure consists of a set. Now, we talked about what a set was in foundations, and we've seen many examples of sets. It also has a notion of equality, and it has an operation. Now, in terms of sets, the simplest algebraic structures use either the real numbers or a subset of the real numbers as their sets. So something like Z, Q, or R, or if we wanted the positives, Z plus, Q plus, or R plus. Or if we wanted the non-negatives, we could have Z greater than or equal to 0, Q greater than or equal to 0. Or R greater than or equal to 0. Or if we wanted the non-zeros, we could have Z star, Q star, or R star. So these are the 12 examples of sets of real numbers that we saw in foundations. And we learned them in foundations because they all make good algebraic examples of simple algebraic structures here. As far as the notion of equality goes, equality has to be exact. For example, it is correct to say 1/2 equals 0.5, but it is not correct to say that 1/3 equals 0.333. Numbers for us have to be exactly equal to be equal. Now, in operation is not what you have at the doctor's office or in the hospital. It is what is a way to combine 2 elements of a set to get a 3rd element of a set. So we saw 4 operations in grade school: addition, subtraction, multiplication, and division. Just like for sets, we saw these 12 examples in foundations. Now, if you think combinatorially here, you've got 12 examples of sets, one notion of equality, and 4 examples of operations, that gives you 12 times 1 times 4, or 48 different algebraic structures that are all familiar, that all involve a familiar set of numbers and one of the 4 familiar operations. Now, where we go in the first quarter of abstract algebra is we look at 6 different properties that we want algebraic structures to have. We will examine the first 3 properties of structures that we want in this lecture. 2 of them are familiar, 1 of them will be less familiar. And this is where we begin our study of abstract algebra.